Okay, so good morning, finally here. So as you've noticed, I've been missing the last couple of Wednesdays, and as I wrote on Slack, it's because I have a problem with the back, so I'm going to do an X-ray next week, and now I've got stronger pills, basically, so that makes this work. So my plan is to go here next Wednesday as well, and just to have a catch up where we are in the course, you could always look at this menu because it will give you a pretty good idea of where we are. Part one ended with the handing off the first assignment. If you haven't handed in the first assignment or forgot to do a release on that repository, please do. We will continuously start watching your repository, so if we get a release, we will, in a fair amount of time, look at your release, and so you can hand that assignment in whenever you like. You who have handed it in and given done a release according to the instructions, you should have gotten some kind of feedback. It could be positive, or you could have some things that you need to fix. Please look at the issues on your repository, because if you look at the issues, me, Jacob, Jan, or Mats will have set an issue on your repository with instructions. Well, that's pretty much it about part one. Part two, we had 2 lectures last week. Those are pre-recorded from last year. So I hope you've watched them. They are pretty up to date. The only thing is that, as you noticed, in the end of the second recording, I started talking about the file structure and such in the exercises and the examinations. That file structure is modified since we are not using Vagrant anymore, and we've simplified the structure more or less. But if you go into the exercise page and look at this, starting out with the exercises, this one is up to date with how the structure is this year. So just watch that one and you will be up to speed. Today we end this second part with a lecture about the AJAX and storage, or more or less asynchronous programming. And this afternoon after lunch we will have the first peer instruction in the course, and I urge you all to be here on the peer instruction. It will not be as fun sitting at home watching the peer instruction over YouTube. I will stream it, but the experience is, well, you're pretty much on your own, so please be here. And the peer instruction is a good rehearsal to the examination, because questions like those we will look at this afternoon, that kind of questions will be on the exam. So it's pretty good rehearsal. Speaking of the exam, next Wednesday is the oral hearing and the deadline for the second assignment. The oral hearing, the time slots for oral hearing, you will be able to book yourself on a time slot. Those time slots will be released on Monday. There will be 4 time slots in parallel, where one of those tracks are here in Växjö, in some of the conference rooms in the B building. And 3 of them will be over Slack or Skype. What is new with Slack is that we are now on a paid plan for Slack, which means that we have better features than before. One of those features is screen sharing, so we could have a call over Skype and share screens. So please, if you before the oral hearing next week, please install the app of Slack, the desktop application, and not only don't just use the browser application, because the browser application will not have that feature of screen sharing. And screen sharing, we've tried it out, it works perfectly on Linux as well. So it's not only Windows and Mac. I mean, if you take the oral hearing with me here, you will not need it. But for everyone else, questions so far? I mean, that will conclude the second part, and the third part is 3 lectures, 1 peer instruction, and 1 bigger assignment in the end. No practical questions regarding the course. Okay, we have a lot of things to cover today. Surprised. So I will kind of, my plan for today is kind of take you on a journey, starting. And the journey will like all circle around the fact that we often from our web pages need to contact other servers or fetch data from servers. And this has been one of the driving forces between, or the driving forces for getting the kind of powerful applications we have today. Because when I started out with JavaScript, the lecture in JavaScript in like 2003, other teachers told me like, but why are you still doing this JavaScript thing? Why don't you do real stuff like Flash and ActionScript? That was the big thing then. JavaScript was looked at as this like toy language that never should grow up, more or less. But something happened, and that this term Ajax was discovered, or it was myntat. I don't find a word for it, but yeah, we coined. Yeah, yeah, maybe. So with that, JavaScript and the JavaScript community like got together and started working in the same direction, and today we have like those powerful applications that we see today. But during this time, the language has evolved as well, from really simple APIs, or not, I shouldn't say simple, well, with APIs that are kind of specially built for one purpose. Today we have APIs that are much more capable of doing things in a modern way, in a modern programming environment. So we will like take a journey from the start to where we are today. If I have the time, probably not, but we will talk a little bit about storage as well. This is not a complicated part, so it will be quite easy to cover. Okay, let's get going. The first thing we really need to discuss is the queue and the event loop. This is a mechanism in the browser or in JavaScript application environments that are essential for understanding how JavaScript works and to be able to program JavaScript in a good way. We'll start by looking at that. We will have a look at asynchronous and synchronous programming. So I will like just want to see some hands raised to be able to see what you have done in the future. How many of you are, for instance, familiar with the concept of promises? Okay, a couple of you. How many has done asynchronous programming in any language? The same, or yeah, a couple of more. How many are familiar with the queue and the event loop in the browser? Yeah, kind of. Okay, good. How many have done like threaded programming in Java? Okay, yeah. So, as most of you know, we have in JavaScript we have multiple threads. In Java we have multiple threads. We are able to do things in parallel. In JavaScript we don't. We could say that we only have one thread. It's not entirely true. There are many threads in the browser for the APIs and such, but when we develop, we could see it as we only have one thread. And that makes a problem. Oh well, I forgot the other parts, but we will come to that. Because, I mean, if you only have one thread, what happens if you write a program and you do like a while through? Oh well, that will lock the thread, because that while through will never leave the stack. It will like run forever, and you will get a Stack Overflow or something, and the program will crash eventually. If you have multiple threads, you could always, like, if you have a web server that just opens a thread for each request coming into the web server, if one request takes a lot of time, doesn't matter, because there is a lot of threads handling all the other requests. However, when we do programming in JavaScript or write a web server in JavaScript, we will only have one thread. That makes it so that you as a programmer, you really need to think about how you design your functions and how you like spread out the work in your functions, because if the function is huge and do a lot of calculations, for instance, and takes, say, 600 milliseconds, then the program will freeze for 600 milliseconds. If the application environment is the browser, in which context we're talking about now, if we are in the browser, that means that the user interface, the whole browser will freeze for 600 milliseconds. Or even worse, if you do like 3-second something, the browser will freeze, completely freeze, or that tab anyway, your tab. So the user will not be able to click anything, the user interface will not re-render, because the main thread is locked. So how does this work? Okay, so we have something that we call the queue. This is a simplified version. I will show you using another, a good simulation tool soon. But think of it as a queue, where you put stuff in from the top and you put them, take them out or pop them from the bottom. First in, first out. Okay, and we have with our JavaScript here. So this function here, or this file or module or whatever it is running, and this is currently in the queue. It will be, I can't draw on this one, and we haven't gotten that one to work yet, so I will point. Hopefully you will see if I could have it like this, I think. So this program is actually running in the queue right now in the bottom. What happens? Well, a function declaration, then we run the run function. And in the run function, we are using something called set timeout. To set a timeout, I think I talked about setting timeouts in the event lecture. So we set a timeout telling the browser to run the function hello in 0 milliseconds. This could seem kind of weird, so we're basically telling the browser to run the hello function in 0 milliseconds. Why not just call the function hello? I mean, if we want to run the function hello right now, why not call it immediately? Well, what happens in this case is that we are telling, with set timeout, we're telling the browser that, okay, we want to run this function hello next. And the browser will take this function call or function reference, see that, okay, we want to run it in 0 milliseconds, and it will add that one to the queue. But since we are actually occupying the queue, the hello function will be halted until we return from the stack. We will then continue running our program. We will log I run. We will log very fast. We will return from run, and then our program will terminate. When that happens, it will be removed from the queue, and this hello function will be the next one in line. And hello will be run, and it will say, when do I say hello? So in this case, it will say, I run very fast, when do I say hello? So it will be executed in that order. And then you see a difference. If we only called hello here instead of setting a timeout, this console log will, of course, be the first one running. Well, why is this important? Yeah, because this queue is shared in the browser, for instance. So think of all the events I talked about last week or in the recording. we had like click events, the user clicking buttons or other kinds of things happening, networks calls or whatever. The browser, as soon as the user clicks a button, the browser will add that function into the queue. So if other code is running, the action when the user clicks will be executed after or in order when there is time in the queue. And if the user spams, it will like add a lot of things to the queue. So if, say, a button click function takes 200 milliseconds to run, because you're doing a lot of calculations in that one, and then the user just keeps clicking like this, faster than 200 milliseconds, then the queue will just grow and grow and grow and grow, because the functions will take longer time to execute than, and there are coming new functions into the queue all the time, faster than we are able to execute them. The same thing with, I mean, if this hello were to add a new timeout with hello, like recursively, this will like occupy the queue as well. This is not the normal case that you write code like that, but it could happen. We could show this more graphically using this tool called the loop. As a mandatory resource for this lecture, we have this one. What the heck is the event loop anyways? This is a talk from a call, like a talk on a conference like 3 years ago, something like that. It's a really good talk about the queue and how it works in the browser. And for this talk, he created this little tool called Loop, which he demonstrates in the talk. So please watch that one. It's really important. But this is kind of the tool, and this illustrates how the browser works under the hood. We have the stack, the call stack, with whatever is running right now. We have all the web APIs in the browser, this being APIs like set timeout, for instance. That is part of the web APIs, like doing network calls and all of those things. They are here. And we have the queue down here, the callback queue. We have a program up here. It's kind of the same as the one I showed. The only difference is that it says 2000 milliseconds instead of 0 up here, just to be able to show it more clear. We also have a button click here. So if I click the button, I think we will see what happens then. So we run the program, and I should probably, okay. Let's see, rerun, pause. Okay, so the first thing happening is that this code went to the stack. We called run, and the run function added timeout to the browser with hello. So the browser will keep track of this timeout and running it for 2 seconds. Resume. No. Okay, so the 2 seconds went. When the 2 seconds were over, this function hello was added to the queue, but the queue is still occupied because this console log is running. So when this program is ready, then the queue could, or this event loop could take the things in the queue, adding it to the stack and running it. That means that this, in a timeout, 2000 milliseconds is not a guarantee. It's a minimum time. So if we write set timeout 0, it just means do it as fast as possible. If we set timeout 2 seconds like this, a minimum of 2 seconds. I mean, now this program is really, really slow, just to indicate there's a lot of waiting going on. I mean, logging to the console will not take 2 seconds. It will be in the magnitude of milliseconds. But if you like, you could experience or experiment with this program. There is a neat function. Let's see if I can find it. Yeah. That will show how the browser renders things as well. Because and I think we got a question in Slack regarding this this week. And I mean, the rendering engine will also be a part of this. So the browser will try to render stuff between when the call stack is available. And we could and in this case it renders every 150th milliseconds or something like that. It's usually like 60 frames per second, whatever that is. So if we run the program, you will see that, okay, the rendering is stopped because the call stack is full. As soon as the call stack was empty, the re-rendering happened, and then when something is on the stack, the re-rendering is halted again. And I mean, if you write code that you anticipate will take a long time to execute, then you should know that the rendering will also freeze during the execution of your code. And when your code leaves the stack, the browser will be able to re-render. So sometimes if you have a program that takes a lot of time, it could be worthwhile to like break it up into parts using, for instance, timeouts. Saying that, okay, this for loop which are iterating over 10,000 objects, it will take a lot of time. Maybe we should like iterate 10 at a time or something like that, and then leave the stack and then continue working. And the browser will be able to re-render. There are a lot of other techniques. We have something called web workers. I will talk about that in the next part. That actually makes it so that we could have more queues, which in practice means more threads. But as for now, we will see this model as how the browser works. One queue, one thread. Of course, there are other threads. Up here, there's a lot of threads because the browser will like start threads for its processes. But we have no control over those. Could you make it? Oh, sorry. Damn it. I forgot. Sorry. I will be in this mode from now on, I think, like that. Okay. But please watch that video because it will be worthwhile. That is the queue. Have this in mind all the time because this is so important. That means we should not write blocking code. Blocking code is bad. There are some native APIs in the browser that has been there since the beginning that blocks the queue. One of the most popular ones being the alerts. The alerts, if you try to just write an alert, you could like do it in the inspector. Hello. Maybe we need those, of course. You have probably seen those on some less fortunate pages. What this does, this is a synchronous call, and it will block the browser. So until the user clicks OK, the queue is occupied. And everything happening in the background will just flow the queue. So if we try to like push something here on like the buttons down up here, or try to execute this link, nothing will happen because this one blocks the queue. If we had timers, the timers will end and add the result to the queue, but it will not execute. Not until we press OK, and the execution will continue. Never ever use alert, never ever use prompt and calls like those, because it will just mess up the queue. Maybe we could run this one actually. Let's see. Yeah. You can see I started the alert. This is on a fiddle. And you can see that even the cursor in the editor is just freezed because the browser cannot re-render the page. So everything is freezed. Until we press OK and oh, the ad down there loaded and things like that. So do not write code like that. And we should learn how to not do that. So asynchronous programming in contrast to synchronous programming. So we are kind of used to think synchronous when we program, because that is how our code normally is executed, right? So we start at the top and we read the code and we follow into functions and we read the function descriptions and we return and we, yeah, you know. And that is a pretty synchronous way of thinking. However, what we often would like is an asynchronous model instead, because we want to do things simultaneously. We would like to load that image in the same time as we do a calculation or we do set up a new network call. So we have this, but we want this, basically. So we could just look at this as an example that, okay, so this purple thing, that is the user doing some interaction. Like we are waiting for the user to write a username, for instance. And when the user has written that username, we could act upon the username. But that doesn't mean that we can't do other things in parallel when the user is writing. We could continue updating a chat, for instance, in the background. With the synchronous module, we would have to wait for the user to write the input, then act upon the input, then refresh the chat. After we refresh the chat, we might be able to load an image or something like that. This will make your applications feel a lot more snappy than the first one. If we look at, I'm not sure this is the best way of describing it, but so the upper part of this one is like the stack, and the rest is just how long things take to do. So starting off here, we just initiate the form for the user to fill in, and then we wait for the user to fill the form in, and this will probably take like the magnitude of a lot of seconds. The yellow part being, what did I say? Yeah, loading the chat. So this is a network call to another server, getting some information back. When we get the information back, we could start presenting this to the user and let the browser re-render the page. So if you look at this code, even though we have a lot of waiting times, waiting for the user, waiting for the network, waiting for something else, you can see that the stack is not occupied. And that's the important part. We do not want to wait on the stack. The stack should just process everything as fast as possible, and then we let the waiting happen in the APIs instead. Compared to if we look at this synchronous model, it will of course be blocked all the time. Thought I had another. I didn't. Okay. Well, let's get back to that. So, when we write our code, it's important that we write asynchronous code. And where this is especially important is when we do network calls. Because doing a calculation in the browser, okay, it might take a couple of milliseconds, but doing a network call, it will take in the best of cases, maybe 30, 40 milliseconds, but often 200, 300 milliseconds. So doing network calls, we want to do asynchronously. So let's start off by looking at how to do network calls. So first of all, we need to be familiar with the HTTP protocol. I think you pretty much are, or? Yeah, pretty much. You've used it. You've used it in the first assignment, at least, when you wrote your hypertext address, or at least. You made a form as well in the first assignment, and then you used, I think you used a get or a post on the method on the form. That form didn't do anything, but we have something called HTTP methods that we use when communicating over HTTP. Those four are the most basic ones. There are more, but you should know those four, I think. The method get is to get the resource, get something back over HTTP. That is what is used when you just like write your address in the address bar of a page on the browser. Post is for putting something or posting something to the server, adding a resource to the server. So if we were to you were to register on a page, you fill up your information, then there will be a post to the server, and the server will handle this post and add the user to the database. That's the post. The put is used for updating. Would be a lot nicer if it was called update, but it's called put, and this is due to reasons far way back when Tim Berners-Lee made this protocol. There is a lot of confusion around post and put, and people mixing them up. That's not that's more of an academic question, I guess, but it could be good to know anyways that post is for new posts and put is for updating. Delete is quite obvious. We should use that when we want to delete the resource. However, if you've done a lot of PHP and doing web forms or things, you've probably only used get and post. And then you use post to telling the server to actually delete something. So you do a post with a hidden field telling that, okay, we should delete the resource. And that's because get and post are the only two methods that are allowed in regular forms on web pages. However, when we use APIs instead of forms for sending requests to the server, we could use whatever HTTP method we like. And this will be even more important when we start to on the other side, on the server, start to design our APIs. Because then we want to design the APIs so that we use the methods. And that is called REST. Okay, just so we know that for now. When we send a request to the server and get a response back, the response will have a status code. And you probably know some of those already because you've seen them. How many of you have seen the 404? Yeah, probably most of you, because I mean, as a web developer, you often do specialized 404 pages. This one being GitHub's 404 page. So I'm not sure. I mean, tech companies usually do things like that. Oh well, wasn't that fun. Well, the 200, the codes starting with 2 and 200 to and up, they are okay codes. Okay, everything, or success. This was a success. We delivered the page you asked for, basically. You probably often want to see the 200. The 300 codes, they are for redirections of different kinds. It could be that, okay, so this resource usually is on this address or URL, but in this case it's moved. So please follow this URL instead. But it's only temporary or it's permanently moved. And this is quite often used for search engines, for instance, to update the registers to know if, okay, is this resource gone forever, or has it moved, or what has happened? So these are for redirects in different ways. The 400 span, if you see a 400 when you write client-side code, you've probably done something wrong. The 400 indicates that it's a client error. So and you could discuss that, of course, but probably you've done something wrong. In the assignment, for instance, when you are going to make calls to our server, you might get a bad request back. So you are supposed to send answers to questions, and if the answer is false or is not correct, you will get a bad request back saying, "Uh-oh, your answer was not correct." You could get an unauthorized. You're not authorized to use this resource. You're not logged in, for instance, or you haven't provided the correct credentials. And forbidden, I mean, that is kind of the same thing, but it's really not. I always mix those up. You could always, I think this one is called unauthorized. It should be unauthenticated. So you're not authenticated, but forbidden says that, okay, you are authenticated, but you're not authorized. So you see, it's an old protocol, so something's wrong. You will discuss those in more details, those of you taking the next course, because they are important when we have a server. The not found, you have provided a link that has no resource in the end. So the server will tell you that, okay, we don't have a resource on this address. Could be that the resource is gone on the server, so it's actually the server's fault, but it's reflected on you since you are the one making the call. The 500 space is for server errors. So if you get a 500 back on the assignment, we have probably done something wrong. Like the database is not answering, a process has died somewhere and not restarted, we are out of memory, whatever could happen on a server. That should be reflected in a 500. Of course, if you try to hack our server, you might be able to trigger a 500 with the requests you do from the client, but please don't. What I want you to know, we could have a question on the exam saying, so what does a 400 error indicate? You should know that that stems from the client, from the server, redirects and success codes. We could have a look at the get, how it looks. If we just look at the plain text being sent from the client to the server, when we do a request, it will look something like this. Could look something like this. So it says, do a get to whatever domain we're at right now, or the domains here, host, lnuserver.se. Try to find the resource / the server page with some get parameter called user ln and a message hello. So in this case, we're trying to send parameters through the URI. We're using the HTTP 1.1 and the user agent is my awesome browser. If you're using Chrome, for instance, it will say a lot about Gecko and Blink, no, not Blink, but WebKit and things like that. I said that in the earlier lecture that don't trust this user agent string because it's just for historical reasons, more or less. But if we design our own API and we are sending our own requests, we could say whatever we like here. It could be good practice if you're like using APIs to actually like have your email address here or something like that. If your script will start hammering the servers, the admins on that side will be able to contact you. So you could use the user agent however you like, more or less. And so we do this request and we get a response back from the server saying, okay, it's HTTP 1.1, the 200 means okay. We have fetched you the content, it has this length and it's of the type text HTML. And then after the header, the code will appear. However, the browser, when you look at the code in the browser, it will filter out the header portion and only show you the doc type and below, or the content of the response. This is the get, and you use this all the time for getting things. However, we're not like, in this case, of course, we're getting something with ln and messages hello, but often when we want to send things to the server, we do not want to do it using a get. We want to send the things hidden, more or less. This is great because the user, in this case, the user will be able to bookmark the page because all information about the request is enclosed inside of the URL. However, if you're logging into a page, for instance, you do not want to send your password and your username in the URL, because this one could be cached on servers or routers or proxies or things on the way to the server. So please do not use that kind of information in the URI. Instead, you could use a post like this. So we say that we do a post to the server web page, and we add the information as a message instead inside of the body of the request. And we get the same thing, response back. But if we should use post or get, that is up to the server. So we need to read up on the API for the server. And on the second assignment, this is something you need to look into, because you will first use get, but then to be able to submit an answer to the server, you will need to use post. And then a get, and then a post, and then a get, and then a post. You will not be able to delete something on the server, because because you will do that in the next course, and we do not want you to delete our questions, even if you will be quite annoyed with them. Okay, so let's do how do we do the network call then? Okay, so back in the days, Microsoft invented something in Internet Explorer 5 that was called the XML HTTP request component. It was already back in '99, I think, and no one really used it. And later on, someone discovered that, whoa, hey, this is a pretty neat feature to be able to use the browser to contact other servers, to load things without reloading the page, to be able to, with JavaScript, load things and getting a result back. So they implemented something called XML HTTP requests. However, that was done using ActiveX, an ActiveX component inside of Internet Explorer. And when Mozilla saw this API and saw it gaining ground, they implemented it as a native object instead into the web API. And that was called the XML HTTP request object. Mozilla reversed engineers Microsoft's version pretty good, so they are compatible, but they were not initialized in the same way. When writing code for Internet Explorer, you had to initiate a new ActiveX component and things like that. But that's long gone, and now all the browsers, including Internet Explorer, are using the XML HTTP request object, and you just do a new XML HTTP request object. And the hard part about this is actually getting the capitalized letters in the right place, I guess, because it's pretty straightforward. So first of all, we do a new XML HTTP request object. Okay, so I've written do not do this, and that's because I will show you why. So the next line, we do an open, and the open will say it's more or less configure this request. Okay, the first parameter is the method, in this case get. The second parameter, or in this case argument, is it's the URL, in this case only data.json. And the third argument, being false, says that this should be synchronous. This call should be a synchronous call. A synchronous call, I should say. Should be a synchronous call. What this means is that on the next line, when we do a send, request.send, what will happen? Well, the call will be made to the server. The server will receive this request, it will start processing it, and eventually it will send an answer back. And when we get an answer, request.send will return, and we will continue on the next line. Why is that a bad thing?
Well, let's say you have a lot of widgets on your page and you want to load information from many different sources. Like, first load will block everything else.
Yeah, so say we have a lot of widgets and things being loaded simultaneously on the page. This one will just block. Yeah, So the key being this will lock the main thread. This will lock the queue. And we cannot do anything until the server has responded. Should we like wait for an unknown server to be able to respond? I mean, we don't know how long that will take. When we develop on our local computer, it will take like 20 milliseconds, but in production from a user in Australia, it will take like 200 milliseconds. No, of course not. We should never write code like this, and this is a synchronous call. You were able to do this up until like 3 years ago. They removed the support of being able to do synchronous calls. So you cannot do this anymore. And you can see why down here, because we lock the main thread until everything returns. A better way of doing this is to do it like this. And this is how you should do it if you are using XML HTTP request today. So we create the object and we add an event listener. You know this. I mean, you can add an event listener for a click, for instance. In this case, we take the request object, we add an event listener, we call it load, and we feed it a function. Meaning this function will be called whenever we get a response back from the server. It's pretty simple. It's the same model as we use for events in the browser, other events in the browser. Forgot to see my colon. I've tried to remove them all, but there was one missing, or one additional. Then we do the setup just as before, without the falsy flag, and then we do a send. However, if I were to write console log request response text down here, what would happen? What would it be the response in the console? If I took this line and added it after send instead. Just copying that line and adding it here. Yeah.
It would log before you get the answer.
Yeah, it will log before we get the answer, and it will just say undefined, because we haven't gotten an answer yet. Then I see solutions like while I less than 200,000, do something. I've seen solutions that, okay, if we write a while loop, that takes a lot of time, and then we get the response. And you try it out on your local machine, and it will magically work. And then we post this on a server, and it will fail again. So of course you should not wait for the response, because then you write synchronous code again. In this case, just do the send, let the browser notify you, and call this function when you get an answer back. Then we will not lock the thread. We will call and send, we'll return, and we can do a lot of other stuff and rendering of the page until we get the answer. Okay? Just before the break, I've already talked about this actually. Yeah. So as I said, Mozilla, Safari, and Opera and the other ones implemented the XML HTTP request object that mimicked the ActiveX component back in 2000. In 2005, Jesse Gareth wrote an article called Ajax, a new approach to web applications. And this one is a classic, because starting with this, developers got their eyes on the XML HTTP request object. It's been there for a while, but no one had really noticed it. But with this article, the revolution began, and he called it Ajax, asynchronous JavaScript and XML. So the X stood for XML. And that was basically because you often got, back in the day, you got XML back on your calls. We don't anymore, we get JSON. But the term Ajax will still be there. You will hear people say that, oh, just do an Ajax call. And when they say do an Ajax call, they are talking about this technique. Worthwhile reading, if you like. Mostly for historical reasons. in 2006, Microsoft added the XML HTTP request object in the same way as the other browsers. That was IE7. Today, you can use it wherever you like. However, there are newer ways of doing things. I will talk about those. No, just. I wanted to be able to do this before the break. So I just want to make you aware of this problem called core, or it's not a problem, it's called cross-origin resource sharing. So when doing requests to other servers, the server needs to be in the game as well. The server needs to say that, okay, I permit you to do calls cross-browser to me. Otherwise, you are only able to do the calls back to your own server. So, for instance, in the assignment where you call this via host free or whatever it's called, the URL, we have permitted applications to talk to that server. And that is a setting that you do in the server. If you're not able, you could, if you try, in this case I tried to load something from sunet.se. I try to contact that page using XML HTTP request. And it just says, no access control allow origin header is presented on the requested resource. We are not allowed access. So we will not be able to access the content on that page. There are many ways to get around this. Something called JSONP was popular, or maybe still is popular, but not that widely used. You could, and the correct way is if you're in control of that server, you could just set the headers that, okay, those domains are able to contact us. If you look at GitHub, for instance, being like, as a developer, you will probably start somewhere in the future to integrate against GitHub in some way. GitHub has a star on the course headers, meaning, okay, all domains are able to contact GitHub. So GitHub is a good source of experimenting against and their APIs. If you construct an API, you will probably do this as well. You could use your own server as a proxy. Just a quick look at that. So let's change the camera. This being the browser where our application is running, this being our server, and this being the server we want to contact. What happens? Well, the browser will request our page, and our page will be loaded in the browser. On this page, there is a script trying to access the third-party server. So we do a request, we get a response back, and the browser will tell us, uh-oh, there are no course headers on the server, so I will not show you the content. How to get around that? Well, instead of doing the call to the third-party server, you make the call back to your own server, and then the server could contact the third-party server, get the response back, and send you the response. So we're using our own server as a proxy to get to this one. Because servers do not have this restriction. It's only the browser that has the restriction. So servers can communicate freely. So if we talk about, okay, but so if you find yourself in a situation where you cannot contact a third-party server, always think that, I can do it through my own server. However, you will need to be able to write some code on the server then. It's pretty much the same thing if you're using Node as in the browser, but you still need to write it. Yeah, now you need coffee, because now we're getting into the mind-wrecking parts. Now we will start talking about callbacks, promises, await, and async. So 10 minutes. Okay. Do you have coffee in the veins? Because now you will really need to focus, because by experience, the concepts I will cover now and until lunch are quite hard to grasp. So focus, 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 okay? Say that, I mean, how many of you have used jQuery? Some of you have used jQuery, yeah. So one popular feature of jQuery is that instead of having to do things like this, setting up event listeners like this and configuring using open and such, they have like a function called Ajax that will simplify the process. And we will now start looking at how to write like our own function or our own module to make this a little bit easier. And I want us to do that because it's really good to see different patterns of doing things like this. And the first one is something called the callback pattern. This pattern of encapsulating functionality is really commonly used in a lot of APIs that you will find when you like download components for the browser or when you use node modules on the server. And the callback pattern has kind of evolved, and everybody is like agreeing on a standard, even it's not being a standard, and it looks something like this. So first of all, the code down below here, that is, maybe we could use the mixed actually, yeah. So the code down here, that is when we use our module, and the code up here is the module. So we could just have a look down here first. So you see that I require a module called Ajax, and that is this one up here. And you can see that this module exports a function called request, and we can call the request on the Ajax object when we require this module. Okay, so we want a function called request, and when we call request, we could just send it some options, and that will do the function calls or the network calls for us. And we do that by doing this kind of function declaration. So we do a function, and we have two parameters, config and callback. Config being, I mean, when you code Java, I think, well, at least when I learned Java back in 15 years ago or something like that, it was pretty common that if you were to call a function, you sent like 5 arguments. If you wanted to do something in the function that had a method and a yada yada yada, you sent those as arguments to the function in a special order. However, in JavaScript, it's more commonly used that you send in an object, a config object, and then you add the arguments inside of the object instead. In this case, we do that. So we send in a config object, and then we provide a callback. And the callback is the function that will be called when this asynchronous call has been executed, or when we get an answer back from the server. Okay? Then we initiate a new XML HTTP request. We add the event listener on load. So when the request is loaded, this function will be executed. We look at the status code. If it's 400 or above, something has gone south. And we call the callback use and add the status code. So we call the callback that the user sent in, and we provide a status code. Okay? We'll have a look at this soon. But if everything is okay, then we call the callback with the first argument being null and the second argument being the data that we got from the server. So this looks a little bit backwards. Oh, wouldn't it be nicer if everything went good, we just sent this response, and if we got an error, we could send null and the error code. Well, this is how the consensus is that you should have it in this way, the error first and the data second. Okay, then we open, outside of the callback, we open and configure. We use the config.method and config.url from the config object to set up the call, and then we send. Eventually, the event listener load will trigger. We will test if the required status was above 400. Then we call the callback with an error code, or else null and the response. So if we look down here, how we use it, then we just do an adx.request. We send in the config object, being method get and the URL data.json, and then we send the function that is the callback, with the first parameter being error and the second being response. That corresponds to what we saw up here. So it's this function that is being called up here when we say callback, because it's that one. Are you with me? Okay. Then we look if this one is not null. So if error, if we have an error, we throw a new error saying network error, and error being what the status code was. I haven't talked about those. Those are called template strings. I'm not sure if you're familiar with them. Do you have them in Java as well? No. But just note that this is using a backtick. If this is called a tick, which is straight, this is called a backtick or front tick. Front tick, backtick. I'm not sure. It's another kind of tick. Like that. And this is the syntax for the templates. So what this does, the dollar, and then we could write an expression inside of the brackets. This expression just fetching this error variable. But you could do like additions and write code here basically, if you like. You could look them up, template strings. And then if everything is okay, we log the response. So we've like done our own request method that takes care of a lot of the things. I mean, it's not a lot of things, but if you go back, this row was like 10 rows, because you had to look if it's in Internet Explorer, you need to start the ActiveX component and yada, yada, yada. So you had to do a lot of configuring. And now it's pretty straightforward, but we try to abstract it anyways, just to learn the callback pattern. And this callback pattern, as I said, it's pretty common still. Okay, so if you get this, we will complicate it even further, because what this will do is it will like, you see, you need to send like functions all the time and act upon the functions like this, and then when you start doing a lot of requests, say that we need to load something, and when we get a response, we should load something else, and when we get that response, we should load a third thing. That's pretty common if you like browse the GitHub API, for instance. So say that, okay, I want to get all users in the organization 1, 2, 5. Okay, then I get a response back with all the users. Then I want to loop all the users, and for each user, I want to call and see how many repos do they have. Then I get the repos back, and for each repo, I need to, and you like have to do calls by calls by calls by calls. What this will create is something called callback hell, or template of doom, or Christmas tree of hell. This has many names, but it will probably start, your code will start to look like this. Mind though, I have omitted all error handling and everything, so this will of course grow. But you see, so, okay, we do a request to this URL, we get a response, we do something with a new URL, and then we do a new request to a new URL, and we will like write code that will eventually end up over here in the browser or in the editor. And it will be like a hazard to debug and to like read this code. And many of you, if you go down this path, you will like find yourself in callback hell. Okay, we need a solution for this. And one of the solutions is something called promises. That instead of writing function like this, we could chain functions. So first of all, what is a promise? Well, the most easy thing to do is, okay, so say that you are going to buy a house. What's the first thing that you will do, at least in Sweden? Well, you will go to the bank, probably, and you will ask the bank, so I'm earning this and that, how much money could I lend for a house? And they will say, well, you could have a house for 2 million. Then they write a note to you saying, okay, we are willing to lend you 2 million Swedish kroner. Okay, then you take this promise and you go to the broker handing out houses and say, okay, so I could buy a house for 2 million. Here is my promise from the bank. And you look at houses, you find a house, you bid, you win the bidding, and then you can buy the house with a promise being the contract, more or less. And you could say to the bank, so, okay, I want to take my promise and get my money and settle the deal. You will not get the 2 million out in cash and then go buy your house. You will have a promise instead. Promises works the same way in code. So a promise is more or less, think of the network call. So when we do the call, instead of waiting or blocking or something like that, we could return a promise. So we return a promise saying, okay, here's your promise. When the call has returned, I will fulfill this promise with data. And that makes it so we could rewrite our function, or our library looking like this. But we start off down here, how to use it. So still requiring the AJAX component. We do the request. We have the config object. Nothing has changed. But instead of sending in a function as a callback, we know that the request will give us a promise back. And the promise has two methods. It has the then method and the catch method. And we do .then, and then we add a function that will be called when the promise resolves, when the promise is fulfilled. So when the data comes, it will call that function that is marked in blue. I have written this as a arrow function instead of with a function syntax, and that's because of space, because this doesn't take up that much space, and it's often you will see arrow function in conjunction with promises. So what it says is this is the parameter, and this is the code being run. So when this promise resolves, this method will be run with data being the thing returned from the promise. If an error something goes wrong, the catch method will be run instead of the promise. Inside of the promise, instead of resolving the promise. So we change this kind of quirky behavior with the callback being null for errors, yada yada, to a defined API that says if something goes wrong, execute catch. If everything is okay, execute then. Otherwise, it's kind of the same behavior as the callbacks. So let's look how we rewrote this. We still have the function request that takes a config object, but not a callback anymore. Instead, we return a new promise. So the request object will return the new promise, and to the constructor of the promise, you will send in a function that has one parameter resolve and one reject. And then we have the same code, but instead of calling the callback when something goes wrong, we just say reject that one and what data should we send. And if it's okay, we do resolve with the response text. So resolve in this case will correspond to then, and reject will correspond to catch. But the promise API will do some things for us in the background. Of course, you could probably call that one then and that one catch, but the code will look quite awkward. And this is like resolve and reject is what most people use for those those parameters. Did you get that one? I mean, it's only a game with functions, higher order functions being thrown around. But this way of writing code, when we use this module, this is a lot nicer. And if we have, for instance, you can read up a lot about promises, but you will notice that for instance, you don't need a catch. If you have a chain of thens, so then this, then this, then this, then you could have a catch in the bottom that will fetch all of the errors, because they are like only being propagated through. Yep.
When you return the new promise, you say like function, and then you have two parameters.
Yep.
So will these two parameters, will they become like functions, because it looks like function calls?
Yeah. So the question is, when I return the new promise, we send in a function with those two parameters, and that is actually defined in the promise that it wants a function taking two parameters, and this will be they are the functions that will be called. Yes, so there are references to those functions. So I mean, yeah, because this yeah. So there are a lot of, how many of you have watched or know who MPJ is? Mattias Petter Johansson. He worked at Spotify as a developer.
Was that the channel
Fun Functions on YouTube? I would highly recommend watching some of his videos as a complement to this lecture. I will link them on the course webpage. He has a talk about promises that is really good, and he will have a talk about something else soon that I will show you. Okay, that's promises. However, why do we need to do this? We need to do this because the XML HTTP request object is a really old API that do not support promises. If you look at the new APIs coming out in the browser and the new APIs being released in the Node community, you will see that they all utilize promises to a great extent. However, this one is so old that promises wasn't invented back then. So we do this to be able to get like promise functionality out of the XML HTTP request object. Wouldn't it be nice if there was an API in the browser that returned promises, so we don't need to do this altogether? Well, there is, of course. So there is, and I will say like new API called Fetch. It's pretty new, couple of years old, but it has good support. So if you're developing for modern browsers, Fetch will be there. And it looks something like this. So the Fetch API will return a promise. So in the browser, you just write fetch. And this is kind of, V3C has has like they always construct those kind of names, like XML HTTP request object or get element by ID. This one is quite good because it's only called fetch, so it's pretty simple. A simple API, fetch, or window.fetch. Maybe you should write window.fetch. I think the standard JS might complain if you don't, but the fetch object is on the window object. So the fetch takes two parameters, or two arguments. The first one being the URL, and this needs to be an absolute URL. It cannot be a relative URL, and I think that's because this fetch API is designed to work in all the new environments in the browsers, being service workers and web workers and such. So we need to use to write an absolute URL, and then we send in a config object. And in the config object, we can configure this this request altogether. I mean, we could say that the method should be post. We could add headers. In this case, we add the header content type to application JSON because we will send in something called JSON in this case. And in body, we put the part that will be sent to the client. In this case, it's this search object that I stringify using JSON stringify. I will get to this as well. I think those are in the wrong order, actually. But this just being the raw text that I want to send to the server. So that's it. That's all you need to do to make a call to another server. And you get a promise back, so you can do .then, and then you take the data. In this case, we take the data and we return the data and .json. And what this will do is it will take the data we get from the server, in this case being JSON, and it parses it to a JavaScript object. That function is a asynchronous function because parsing a string could take it quite a lot of time. So if you parse a huge string, it could take time. And if it takes time, it will lock the thread. So this one is made asynchronous. So it will return a promise. So we have to wait. So we return, in our case from this then, we return the promise that this parsing will be done somewhere in the future. And then we act upon that. So when that happens, we take the parsed object and we get something out of it and we log it. So you really don't need to care so much about this part because you miss some information to be able to read this. Or maybe, well, maybe I could run this for you. I have the time, right? Yeah. Then it will be more obvious, I think. Let's see. I did not prepare this, so I could try anyway. Do I have it? Yeah. That one. Oh, shite. Let's see how much is wrong. So first of all, I have no time to run this in the browser. So I will run this in Node. And the fetch API is not available in Node. So I need to require a module for fetch. But if you're in the browser and running this code, then you don't need to require this module, basically. I will show you a neat plugin that I learned about yesterday. Quokka. What? Oh, there, start on current file. So I will actually just start to run it. It will give me some real-time information. It says that it cannot load because I've not done an npm install, yada yada. Quokka could help me do that as well. Quokka, install missing package. We'll install that one and reload the code, hopefully. Yeah, okay. So, the API, if we just do something like that. If we look at, I mean, this one, data, return. What this will tell us is now we see what we get in response from the server. So this is what we get from the server. We get a response object. But on that response object, we could do a .json. Like that. But that .json will return a promise. So this isn't that good. Get some more, and then we're back. Oh, I'm not sure how I'll show this search stream. Can't I? Om vi gör så. Yeah, so what you will see here is that when I parse the JSON, the response from the server, and we look at what we get back, we will get this one, an object with the first being search string live, which is the one I sent in, and we get a match. So this is a search API. So if we send in the ticker for a Premier League team, we will get information about the team back. So when I send in live, I will get a match on Liverpool. If I send in man, I will get Manchester United and Manchester City back. However, if I only want the matches, I could do like search.match, being an array of all the teams. So that's why it looks like it does. I'm not sure, maybe we could just, blob is not a function. I'm not that. Wasn't it like that? Ah, well, whatever. I should not make examples up on the go. Instead, we will continue, because even though we use promises, we can find ourselves in the situation, which is pretty good actually, that we start nesting a lot of thens. And this code, as you see, is quite hard to get a grip on, because it's a then it sends that to that arrow function, sending it back. So we have a new way of doing things called async await. And, well, it's this one, actually, first of all. So instead of writing it with all of those then, we could do something called asynchronous functions. And this is pretty new, but it's good support in the browsers, the later versions. What that makes us do is like write asynchronous code that looks synchronous and reads synchronous. So if we look at this example once again, it's the same example, but I've rewritten it, and I've created a function called getAllTeams. I say that this is an asynchronous function by the keyword async in the front. An asynchronous function will always return a promise when it resolves. We send in the query, and the query being just the string that we want to search. This is a new thing as well. So we send in the query, so this is a string, and then we create an object, a search object, and we only write query. What that will end up being is query : query. So this is just a short of writing query : query. So you can shorten it down if the property will have a value that is has the same name in this block. I can show you soon. Then we configure the object. That is the same thing as before, with the headers and with stringifying the search. Then we call the fetch function, just as before, but instead of doing .then, we use the keyword await, and then we get the data back. So this is quite, I mean, it's a lot of things happening here, but what will happen is that the browser, or the queue, the JavaScript interpreter, it will find the await keyword, and it will do all the binding with the promises and things in the background for us, and it will actually stop the execution of our code and release it back, release the queue. And when we get a response back and fetch returns, it will continue to run. So you could like see this as the code, it looks synchronous because it actually stops here and waits. And when we get a result, the next line will be run, and because data.json is asynchronous as well, it will wait for that one, and then we will get the JSON, and then we return the match. So when we use this one, getAllTeams, remember that even though we return JSON.match, we will get a promise back with the parameter in the promise being what is returned from getAllTeams. And then we could log it. So this is pretty neat if you want to write, I mean, because it does exactly the same thing as this one. But it's a lot easier to read because we could read it line by line as we're used to. So if you need to do a lot of things in like a sequence, async is the way to go. If you need to do a lot of things in parallel, this is not the way to go, because you can't start a lot of things in parallel, but you can, using regular promises, you could just start new promises or new fetches, and they will all go in parallel. In this case, you will always have to wait in the function. Yes?
Also use generating functions, right?
Huh?
Generating functions?
Yeah, so the next thing is generator functions. I will not go into those. Not now, but if you want another step, there are something called generator functions as well. But I will not look upon those. MPJ has a really awesome video about this. Please watch it.
SQL query,
Whoa. Damn, I have no controls. But they are quite...
I didn't make that up on the spot, just so you know. All right, so what you see here is...
those videos are real. He's made a lot of editing to those videos, so they're worthwhile to watch because they are quite short, but they get a lot of things covered. He will cover more or less everything that I said during this last hour in 20 minutes. So please watch that one. Okay, I will leave, but I mean for the assignment, you could use fetch. You could use XML HTTP request. You could use callback patterns. You can use promises. You can use async await. Up to you. The second assignment is pass and fail. Third assignment is graded. Just saying. So I mean, we will not judge you if you used XML HTTP request or if you use whatever. But in the last assignment, it would be nice to start looking at those things. They are simpler as well, so I mean it's easier. I've talked about JSON. I have a couple of minutes. This one should have been in the beginning. I see it now. So JSON, JavaScript object notation. XML was the thing back in the 90s. When they made XML, they kind of looked at all the programming languages and said, okay, we need one format that will rule them all, that will have like the capability of expressing data in every language. And it became a quite expressive format. So XML, you could probably express everything with XML using attributes and scopes and things. However, that also makes XML quite cumbersome because there's a lot of things you need to know and it's quite a lot of overhead on data and stuff. When Crockford, he says this himself, he discovered JSON. He will not take credit for inventing it because he said, I just discovered something that was already there. He took another approach. He looked at all the programming languages and thought, okay, so what is like the common ground in all languages? Okay, we have numbers, we have strings, and we have objects. Okay, let's make a data format that supports those things, arrays, null, and booleans. He looked at like the bare minimum and he made and saw that JavaScript objects are pretty good because they could be expressed in all languages. You could easily take a JSON object and convert it to PHP or Java or whatever. So it's only a subset of JavaScript. In JSON, you cannot write functions, for instance. It's only a data protocol. It's you can read about it here. The data format is, or the file extension is .json. It's in the RFC 4627. Could look something like this. If you look at this top, this is JSON. The only thing that you will see that is different from what you know is that you need to write the properties using quotes, single or double. And that's because different languages have different reserved words. So something could be reserved in Python that is not reserved in JavaScript and the other way around. So, but with quotes, that's okay. You can write whatever inside of the quotes. Strings, numbers, booleans, null, object, and arrays is what you can have in a JSON file. You can have an array like this, an array of objects. I would urge you to use something called a lint when you start experiment with JSON. So we have this JSON lint. You just paste your JSON code. No, they have changed something. And you validate, and you will see, okay, this is valid. If I, however, forget the quotes, yeah, it will say that we have an error because this is not valid JSON. So a good practice could be if you send a response to the server, you could always like just fetch the response, or I shouldn't say fetch, just log the response and put it here and see if it's okay, if it's valid. However, often you don't need to write the JSON by hand. You will use a tool like JSON parse or JSON stringify. JSON.stringify will take an object and convert it into JSON string, and parse will do the opposite around. So if we have an object like this, a JavaScript object, and we do JSON.stringify on that object, ob will be a string with JSON. You can see it here. So it's below object, then it will be a string, and then we do a parse and it will be an object again. However, JSON.parse is synchronous. It's not an async function, it's synchronous. That's why we used the JSON, the built-in to fetch one that was async instead. But it's okay to use this, at least for smaller amounts of JSON data. It's the preferred way in the browser anyway. You will learn to love JSON because it's so simple. It's so easy to work with. You will find if you open Java, you could take a JSON object and you could just do something similar like parse in Java, and it will be Java objects instead. So it's really simple. The last thing, I will not say much about it. Well, I have a demo where I work with forms. It's called autocomplete. It utilizes this API that I showed with football teams. Please watch it. However, I stop at promises. I do promises, but I don't do fetch and async. I will hopefully I will add it in the future. In the near to come future, I hope. What I didn't have time to cover, as I said, is storing data on the client. I would just want to say that you have 3 methods of storing data: cookies, web storage, and IndexedDB. Cookies you will kind of use sometimes maybe, but if you want to store data in the browser, you will use something called web storage. It's a simple key value database where you could store JSON, for instance. You could have like a config object and you store stringified JSON objects, and then you can read them up again. There is an IndexedDB. That is if you want to do bigger data calculations with a real database, then there is, but we will not cover that in this course at all. Cookies, I will not say anything about them. Web storage, it's a really simple API. Local storage.set item like that, and get item like that. It's just key value. It's synchronous as well. It's not async. Not that I'm aware of anyway. And of course, as I said, you can store JSON as well. You just stringify something and store it. In this case, I've made an object, I stringify it, I store it with a key style, and then I could read it back by using JSON part and getting the item style. You could look at this example when you try it for your own. But it's simple to use. There is never a problem with that. If you're using one of those APIs like storage, cookies, then you should, by the law of electronic communication, you should notify the user. You have seen them all over the web. This site is using cookies. Do you agree? Okay, and so forth. If you go to polisen.se, they will have one as well. I accept cookies. However, if you look in the browser, they have already set the cookies before you accept. That is not okay, but I don't know if someone would care. Okay, this law is kind of written a long time ago, and it's not up to speed with anything, but however, you should kind of follow the rules, I guess. Okay, lunch. After lunch, we will have the peer instruction. There will be questions. Please have a smartphone or a computer with you. Smartphone is fine. Okay, thank you.